So I'm going to be showing you how to solve some elevator problems. I have 3 in this video. All 3 of these refer to the same person in the same elevator, so it's kind of a continuous question here. All right, so a 60 kilogram person is on an elevator at rest. When the elevator begins to ascend, the person feels a 700 Newton normal force from the floor. Determine the acceleration of the elevator. Okay, so I'm going to start with a free body diagram. That's usually a good idea. So this person is 60 kilograms. There's a force of gravity downwards on that 60 kilograms. And sometimes you will see me calculate the value of the gravity right away if I know the mass, because that's a quick thing to do. And I mean, sometimes it's helpful to know some more numbers earlier on. So the force of gravity is m times g, so it's 60 times a 9.8, as 9.8 is the value for Earth. And I'll multiply that out. Just let me get a calculator here. Okay, so I calculate that to be 588 newtons to 2 sig figs. And then there's also a 700 Newton normal force upward. So I'll draw an arrow a bit longer than the force of gravity because it's larger. Okay, so that's the free body diagram. As you can see, the upward force beats the downward force, which makes sense because it says the elevator starts at rest and starts moving up. So the only way to do that is if it can accelerate up. So in order to determine the acceleration, use Newton's second law. So this right here is Newton's second law. Just because this week we're focusing on gravity does not mean that we forget about the previous stuff in the unit and even the stuff from Unit 1 as well. All right, with this, I have pretty much everything I need to get the acceleration. My net force, it's just easily based on the diagram, it's 700 newtons up, and then it's being resisted by 588 newtons down, so I'll say minus 588. That's going to be the net force, and the mass is given right in the question. It's 60. Okay, maybe I should have listed that in the beginning. It's good habits to list things out. So then I will calculate that out in a calculator. And my calculator is giving me to 2 significant digits. I round it to 1.9 meters per second squared. And the direction is going to be up. All right, so that's one example. We're going to keep going here. Number 2 says the elevator is now moving. Actually, that should say, there's a mistake there. That should say up. The elevator is now moving up at a constant velocity. Determine the normal force on the person. So this one should be really quick, and it'll be really quick as long as you recognize or catch these 2 very important words: constant velocity. Constant velocity means forces are balanced. That's Newton's first law. Okay, so I'll just write that there for you just as a reminder. So if the forces are balanced, then the free body diagram has the force of gravity equaling the normal force. So I'll write the statement out. Normal force equals force of gravity in magnitude. And the force of gravity, we know the formula for that, it's mg. And then I calculate that out. It's this is the same person, okay, 60 kilogram person times 9.8, which I already figured out in the previous question is 588 newtons. So that's the 2 sig figs. My final answer, I will write a statement that the normal force equals to 5.9 times 10 squared newtons, and give the direction of the normal force, which is up. Okay, so that's when the elevator is going at constant velocity. Number 3, the elevator moving up slows down as it reaches the desired floor. The magnitude of the acceleration is 1.5 meters per second squared. Determine the normal force on the person. Okay, so it's the same person, same elevator. So same person, 60 kilograms. Do the free body diagram. So it gives you the magnitude of the acceleration, but it's very important for you to think carefully as to what direction the acceleration is. Because whatever direction the acceleration is, that's the winning direction for the net force. Okay, so the elevator is moving upwards and it's slowing down. Okay, it's moving up and slowing down. When I visualize that, that means that the net force has got to pull downwards. Okay, the acceleration has got to be downwards to be able to slow down the elevator that's going up. So my downward force is going to be larger than my normal force. So I'll make sure I draw the normal force shorter. Okay, my force of gravity is 588 from before. Okay, that doesn't change. The force of gravity never changes in any of these elevator problems. It's always m times g for the force of gravity. It's the normal force that changes depending on the acceleration. This is what we have to find out. Okay, the acceleration is 1.5 meters per second squared down. That's given in the question. Okay, so all of that there, that is my setup, my list of given information. Some of it I wrote out in the diagram. Okay, so how do I get this normal force? Go back to Newton's second law. Actually, I'm going to write it in this format. This is actually how you'll often see it written, F equals ma, because there's no fraction there. I use this rearrangement of the formula if I'm solving for a force, and I'm solving for a normal force, so I write it like this to kind of avoid the fraction. Okay, now in terms of magnitudes, the force of gravity is bigger in magnitude than the normal force. So my net force, the magnitude of it, is going to be the force of gravity minus the magnitude of the force of normal. And that's going to equal to m times the magnitude of the acceleration. Okay, so that is switching net force with what it is. It's gravity minus normal in terms of magnitudes. And I'm going to rearrange that to get the normal force. So actually it's just going to be I'm going to move this to the right side by adding it to both sides. And then I'm going to move the MA to the left side by subtracting it from both sides. So it's going to result with just a normal force isolated on the right side, and then force of gravity minus MA on the left side. So I can solve that now. The force of gravity is 588 to 2 sig figs minus the mass times acceleration. So 60 is the mass, 1.5 is the acceleration. So I've got to figure that out. I think that would be 498. To 2 sig figs. So my final statement, I will write that the normal force as a vector equals to 5.0, because that rounds to 500 times 10 squared newtons up. Okay. So those are some elevator problems. So on Google Classroom, there's a couple for you to practice, and it's in a hand-in folder so that if you want, you can submit it to me and get some feedback on it. Okay, we'll see you next time.